Let me check if you're online. As always, blah blah blah, and we are online. Nice. Okay. So before I actually start working, I want to figure out which binaural binaural. I don't know how to pronounce that. Which binaural beats frequency is the best for either ADHD or focus. Um, yeah, because yesterday I've been using binaural beats for the whole day, and I don't know if it was placebo or not, but I felt a little bit better. So let's see. Mixed and inconclusive. Wow. Yeah, I've heard somewhere that it's not like super scientific. But at the same time, I remember reading one paper, I believe it was about ADHD people, and the binaural beats caused some kind of, because it's like uh async, or like, it's not synchronized, it's like left right. And in an ADHD brain, it causes some part of the brain to actually like synchronize or something like that. But I'm not entirely sure about that. Oh, 10 hertz. Memory consolidation, alertness, concentration. Yeah, this is what I like don't understand. Like, attention, how is attention focus different from concentration? I think it's the same thing, right? But as you can see, 10 versus 12 to 30, it's a pretty big spread. A VR-based study using 10 hertz audiovisual entrainment showed improved attention and spatial learning in 72% of ADHD subjects after 20 days of 15-minute sessions. Wow, that's actually really good. I don't know why it's inconclusive. Like 72% of ADHD subjects, and they only used it for 15 minutes per day for 20 days. That's pretty good. A visual spatial memory study found 10 hertz binaural beats produce significantly faster reaction times. Oh, so like if you're if you're like playing Call of Duty, would it be good to like listen to 10 hertz binaural beats? Would it like help you increase reaction times? That's interesting. Studies showing no effect were not beneficial for sustained attention in either neurotypical or attention deficit subjects and may disrupt beneficial brain activity patterns. Damn, that so it might be like counterproductive. No significant changes in brainwave. Yeah, but like, correct me if I'm wrong, but I think different brainwaves don't have to necessarily mean that it's not better for concentration. I don't know. Uh, no frequency. Okay, so 10 hertz should be the best. Only some people respond to binaural beats. Okay. Ooh, audio visual. Yeah, but I think that would be too disturbing, right? Yeah. Mm. Also kind of interested in white noise because I know a lot of people swear by white noise. So let me look that up. I just want to see what's like the best thing. Ooh, a lot of errors. Name. Damn, stochastic resonance noise ADHD dopamine. It's looking up very interesting things, very interesting queries. I was actually thinking about like making my own what would you call it? I guess a database based on PubMed for like quick AI information retrieval, because when it just searches PubMed like this, yeah, I'm actually not sure how they handle the query. Maybe I would just be duplicating their work. I'm not sure. White pink noise for ADHD and focus research. White and pink noise have stronger research support than binaural beats for ADHD and attention. Ooh, okay. So white or pink. Small but significant benefit for individuals with ADHD. Negative effect for non-ADHD. Oh shit. Results were consistent. Okay. First mechanism. Tonic dopamine levels. Children. I have no idea what's oculomotor inhibitory control, so I don't know what they talk about. Non-random sounds, pure tones, produce the same benefits as random noise. Oh, okay. Oh, so like if I just listen to the tone, like pure tone, at some kind of frequency, is the same as like that same noise, but like randomly in a noise. Pink noise and 100 hertz pure tone. So pink noise, white or pink. Harm to non-ADHD. Well, that's gonna be interesting. Is this like an ADHD test? Like, could you use white or pink noise to test if someone has ADHD? I guess it's just a small effect, so it's not possible. It would be an interesting thing, right? Okay, so they've mentioned pink noise, I guess one more time than white noise. So I think I'm gonna try pink noise then. Ooh, where do I find it here? Is he here? Ooh, that's hard to navigate. What is all of this? Rain noise, singing bowls, white noise, pink. Oh, I see. Tape speed. Okay, I don't know what that does. Okay, I guess that's it. My first feelings are that this is more uncomfortable to listen to than binaural beats. But okay, I'll see. Speech blocker. Interesting. Okay, whatever. I just wanted to experiment with things that might help my ADHD brain to focus a little bit better. Okay, I think I need to bring up this. This. Yeah, I just want to keep this here. Blah, blah, blah. Okay, and I want it to go here. Okay, great. Yeah, maybe I'll find out that actually I'm not ADHD at all, and this is just too distracting and disturbing. Uh, by the way, if it bothers you listening to the pink noise, then just let me know and I can just completely mute it for you guys. Okay, so in the past week or so, I've been working on this thing that I've named QuickScope now, and Here's AI generated README based on what I told it. But basically, there is this library. It's called SIP. SIP. Yeah, but it's not this one, the solving constraint. Oh yeah, it's the one from SourceGraph. So it's Code Intelligence Protocol. It gives you a bunch of metrics, metrics of the code, and then you can search. I actually don't know what are all the things it includes. Relationship. Yeah, that's definitely one of the things that we are going to be doing. Um, yeah, I just wanted to check out all of the metrics. Yeah, but they have slightly different goals. Guys at SourceGraph with Skip. I think I'm supposed to pronounce it as Skip. They want to use it for code navigation. So the metrics are kind of like a side effect of that. Yeah, but previously I was using some of the metrics from Skip to kind of string together a proof of concept kind of project of QuickScope. And the second was Rust Code Analyzer, which is way, way closer to actually what I'm doing. It's actually really close because it also uses TreeSitter. It's also based on TreeSitter. So it walks the TreeSitter tree and it tries to compute metrics. And those metrics are, okay, where are the metrics? Supported metrics. Okay. And so it has all of these metrics, assignments, branches, conditions. Interesting. They have conditions and branches as different things. Okay. Number of lines where some are blank, some are comments. They also compute cognitive complexity, also Hallstatt, I don't know how I'm supposed to pronounce that, the maintainability index, number of arguments, exits, number of functions and closures, which in our case is kind of just the number of scopes we have. That's why it's called QuickScope. We just quickly analyze the scopes. So most of these tools, like I'm actually not sure about Skip. Maybe I'm wrong about Skip, but I think Rust code analysis works based on functions, and a lot of these tools just work on the functional level. Um, but for my use case, that's not enough because I need granular information. I want to be able to drill down, and I'm gonna get to the reasons right after this. Yeah, so oh, it also has cyclomatic complexity. So in my eyes, Rust code analysis does both raw metrics. So raw will be like number of branches, conditions, functional arguments, exits, and so on, but also derived metrics, which are based on these raw metrics like cognitive, cyclomatic complexity, Hallstatt, and the maintainability index. So I will move these derived metrics into the database, which in my case is going to be ClickHouse, most likely. And that is because I want to be able to play with it, without having to recompile, like change and recompile Rust code. So QuickScope is going to aggregate or compute or whatever only raw metrics. And now the whole reason why I'm building all of this and why I'm not trying to reuse tools like Rust code analysis or the skip uh, code intelligence protocol or other tools um, are performance. I've tried using these. That was the first prototype or proof of concept, whatever you want to call that. And um, what I did, and now we're getting a little bit closer to what actually QuickScope is. What it did was that you pointed it at any public repo or a repo that you have access to, and it went to the very first commit. So here, it would just go all the way to the very first commit and look at how the repository looked at that first commit by running all of these analysis tools. Then it would jump. In my prototype, it jumped by a month in the commit history. So it just grabbed the closest commit to the 1 month offset and do the same. It would just keep jumping like this. And what it would give you is, for example, when it comes to if we look at the aggregated statistics for the whole file based on these, we can take median or average or anything like that. So we could, for example, look at the number of function arguments per file, right? So that would be some kind of average or median. And we could look at either the average or median over all the files in a whole repo. So maybe we would see, um, our functions are getting simpler, or more realistically, our functions are getting more complex, meaning they, on average or median or whatever, have more and more arguments, which means the complexity and maintainability and all of that is getting harder and harder, or higher and higher. Um, However, because I used Rust code analysis and skip, and they are the kind of fastest um, tools that do this in their own categories, but still it was way too slow. Like I have one repo. It has right now it has 1,300 TypeScript files, TS and TSX files, and something over 2,000 commits over the span of 3.5 years. And going through that history and aggregating all of these metrics would take, on my M2 Max with 64 gigs of RAM, something around, I don't want to lie, but it was something around at least 10 minutes, which for my use case is like completely unacceptable, right? So I just needed something which is super, super fast. And I'm not trying to build a general open source library like probably these guys were trying. So obviously that kind of forces you into design decisions that might result in a slower software, right? Because you're trying to make it general. I'm not trying to do that. I'm building this strictly for my own use cases. So I'm trying to squeeze as much performance as possible because ultimately, I don't want to be jumping in monthly or weekly increments or even daily. I want to literally be jumping commit by commit and incrementally doing these or computing these statistics. So in the end, I have per commit statistics of the whole repo at that time of that particular commit. And I had these statistics over the lifespan of the repo, which then gives you pretty powerful suite of metrics that you can use to make certain assumptions about the repo or about certain files or about, in my case, the complexity, and where that complexity lives. And if we target those places, then we can decrease the complexity, right? And for that, we also have to figure out which places are the hottest places, in the sense that if we fix this one issue in this one file, um, kind of like in percentage, how much complexity will it actually fix, right? Because if we fix some very messy file that's used in one place, in one endpoint that's like rarely used, it's not really going to help, right? But if we fix a moderately complex file that's used in 1,000 places all over the repo, then it's going to help a ton, right? So that's kind of the goal of this whole project. And ultimately, I, as in human, I'm not the target audience. Humans are not the target audience, not necessarily of this project. Uh, it's actually AI. It's AI agents, and I call them minions. So these minions, they will wake up. There's kind of going to be a cron job. You can think about it as a cron job, and you can set it to whatever value you want. So you can wake up these minions once a month, or once every 5 minutes. It's completely up to you. But in either way, they wake up and they look for problematic code, right? So without this project, that would be pretty hard to do. Sure, you could spin up some kind of AI agent that spins up a bunch of exploration sub agents, and they try to, in their own way, score the code, and then at the end um, you can estimate that some files are more complex and need fixing, right? Uh, but in my experience, that's not the best way. And also, it would be pretty expensive. So what's way better is to have some kind of static analysis, very cheap thing you can just run per commit. And then, actually, before the minions wake up, there will be some kind of project manager AI agent, and it looks at all of these problematic files. It also sees if there is maybe already a PR open and not closed or merged yet, so it can skip those files, right? Because we want to minimize conflicts when it comes to these minions, right? Because I think it will be a bad user experience if their work kind of overlapped and then someone would have to deal with the conflict. So there has to be some kind of like locking mechanism where the minion kind of claims or locks the file, and then it's locked until the PR is merged or closed. Yeah, so the AI manager looks at all of these hot files. It filters out the ones that are locked, and it looks, I guess, it could look through the especially problematic parts, right? Because the the scope here is here because we have scope level granularity. So it looks at all of the scopes in a file, and it knows which scope is the hottest, right? So in other words, which one is most worth fixing. And it also, because it has all of those metrics, it knows what is wrong with that scope, right? So it knows maybe there's too many exit points, right? So uh, this project manager could create tasks, specific tasks for specific parts of these specific files for the minions to work on. And then the minions, through mad multi-agent debate, they uh, come up with their own specialized solutions. So there will be like a security minion, there will be performance minion, there will be readability minion, and so on. And through several turns in that debate, but usually, from what I've read in the research, usually just one round is, or one turn is enough. So I'll see if there will be any need for multiple rounds. And then at the end, there is some kind of a judge that looks at the proposed changes, uh, the the critique, because uh, every minion comes up with a plan, and then every minion sees all of the other minions' plans, and they can critique it or they can agree with it. And then there is defense. So uh, the the minions get each minion gets critique of their own plan from all of the other minions, and they can defend themselves, or they can agree with the points, and then at the end the judge sees all of this, and based on that the judge makes a decision of what should be done. And obviously in the UI, when it comes to the user that's going to use these minions, they can give different importance to different minions. So for example, they don't care about performance that much, right? So they just slide the performance to be smaller, which means that when it comes to cases where it's kind of 50-50, the judge can look at these ratios created by the user and do a more informed decision. Yeah, that's it. Whew. Okay, so that's kind of the whole idea. And so what all of this requires is to do a static code analysis on top of TreeSitter, because right now that's kind of the best standard when it comes to parsing code. Also, the code doesn't have to be complete, which is also pretty nice. And it can also work in an incremental way. Yeah, so we are building QuickScope on top of TreeSitter. Here in agents, because I'm not a really Rust developer. That doesn't mean that I don't like or do low-level programming. I do program in Zig, but unfortunately, the packages are not that mature. So I kind of concluded that it's going to be better to just use the right tool for the job, which in this case is Rust. So I'm kind of co-developing this with Claw Code. Yeah, so the last time I did something was I gave all of these explanations of future plans and just let it update the README. Yeah, but I also just ask it like about general Rust syntax and let it implement some smaller things. I did have one version that was kind of like 90% just AI, and it kind of worked, but the architecture was shit. No, okay, it wasn't shit. It was okay, but it could be better. And the code was kind of all over the place. So Now this is actually the third version and hopefully the final version. Yeah, so I have this pretty kind of strict agent MD, I would say. So I just tell it that it's a like a senior software architect engineer with over 50 years of experience in low-level programming. Uh, yeah, performance is important. We count every single CPU cycle and every single bit counts. Yeah, it has to. I found that this one sentence really improves the output. So you create solutions to problems in a systematic, holistic, maintainable, and clean way. This really, if any, like if I had to pick one sentence from this whole thing that makes the biggest impact, is this one. Yeah, it should base all of its decisions on like scientific papers, benchmarks, and just pure facts. It's deeply familiar with assembly, modern CPU architectures, memory layouts, and how networking and I/O works. You never build anything based on assumptions. When in doubt, always ask until you have a clear and reasonable answer. Blah, blah, blah. Yeah, there's some project context. Yeah, I gave it a performance target, which actually is kind of a lie. I don't think we're gonna be doing millions of files per second, at least not at first. But it's a pretty nice target to have if we want to squeeze as much performance as possible. And we have zero tolerance policy for function pointers and unnecessary indirection, which was kind of a shortcoming of the previous two versions, which were which used a lot of pointers, a lot of indirection. There was a lot of data copying and cloning, wasted space everywhere, CPU instructions completely wasted. We were missing cache, or we had a lot of cache misses, um, and our data structures definitely didn't fit in the cache lines, or they weren't packed evenly. So these are, yeah, zero tolerance policy. We really have to follow these. Yeah, the library has to be absolute fastest in its category, no compromises. And what's kind of very important when it comes to the high level architectural constraints here is that it has to be single pass over the TreeSitter tree. So technically speaking, it doesn't have to be single pass. Like in general, there can be some secondary data structure that we build as we walk the tree, and then at the end we also walk that one. So it's actually two pass, but here the single pass means single pass over the TreeSitter tree, because that's like the most expensive thing when it comes to the performance. Ideally, no heap allocations during traversal. Again, this is kind of a lie, because obviously we're dealing with like dynamic, like we we don't know, or we cannot be sure what we're going to allocate or what we're going to need, right? So yeah, so this is not entirely true, but you'll see that I try to limit uh, like uh, for loop bounds and uh, vector sizes and stuff like that. So at least we try to minimize this as much as possible. It has to be cache friendly. I try to inline all the hot paths. I actually don't know if this is like super good idea or not, but I thought this could be like an easy win, hopefully. So right now we're just trying to inline as many things as possible. We just don't inline things that are rarely used. So if you like create the stack once, or you uh, transform the scope builder into result just once, then it doesn't really make sense to inline it, I think. Yeah, so when it comes to the planned future features, then we definitely want dependency graph. What I mean by dependency graph is file to file imports, and and weighted edges, which means how many times the imported symbols are referenced inside the code. Yeah. And for that, obviously, we need symbol tracking. So in each scope, we have to know which symbols were created. We also have to support hoisting, which makes the whole problem a lot harder, because also there are different kinds of hoisting. So that's kind of yeah, it's hard. Yeah. So for example, some hoisting is just like local block, some is like the local function, and some can be global. So I don't usually write Python, but I know that in Python you can kind of like say global and then the name of the variable, and that makes that variable global, even though you've just declared it inside a function that's like whatever levels deep, which is kind of counterintuitive and I don't know, kind of I would say a mm, bad design, but whatever. Yeah, we're gonna store everything in probably ClickHouse. And here's the power of 10 rules for developing safety critical code. Yeah, if you don't know, this is, I believe, from NASA, and it's just 10 rules for writing very, very strict code. You know, because they obviously have zero tolerance policy because it can cost billions and it can cost lives. So I think it's just kind of a good idea to follow this, not 100%, you know, not completely strictly, but it's a good like recommendation, I would say. Whew. Okay, so yeah, let's look at uh, the general structure of what we have here. So right now I have this QuickScope repo, and you can notice that here we have 4 crates. Um, so like why, right? So the QuickScope one, which is the main one, right now it just like includes the dynamically generated QuickScope RS. So I know I said no indirection. This is pretty indirect, but you'll see why. It's just bunch of tests, and there is a build RS, which is very important. And here we say QuickScope build run. So I've kind of moved all of the build logic into its own crate, which is this one, which is build. And this is actually where most of the stuff happens. So I'm just going to skip it for now. There is QuickScope core, which right now just holds some uh, core things that are imported somewhere else. And mostly it's imported and used in QuickScope languages. So I wanted a single kind of separate place where people can add and maintain and implement new languages for this library to support. So right now there are just 2, and they're not fully implemented at all. Yeah, but there is a TypeScript, like TypeScript, and then there is TSX. Both are in this TypeScript RS, and here we use the language definition from the core. So it's just a pretty static struct, and where was I? Here. And we use this language macro, which is just in slightly nicer way lets us um, uh, create an instance of this struct, of the language struct. So here we just say the name, the extensions that this is for, the language, the TreeSitter language or grammar. I don't know what to call it, but here they use language TypeScript, so I call it language too. And then there is handlers, which is kind of an abstracted match statement. So these are the arms of the match, basically. So we say if it's a program, so the node in the TreeSitter tree, if its kind is program or else clause or finally clause, then we create a scope for this node. Here you can see that you have no idea what's builder, you have no idea what's node. It kind of like appeared out of nowhere. So I guess this is going to have to be documented somehow. I'm not sure if we can give some hints to Rust that actually this builder is uh, the builder defined somewhere completely else, and this node is the TreeSitter node. I don't know if we can do that, but that's what these two things are. And then on the builder, you just slowly build the result, and it's scope based, right? So once you create a scope, it's or let me say it like this, it's stack based. Yeah, so it's a stack of scopes. Yeah, so once you kind of like push the scope, you create a scope, then everything you do after that is done on that scope, on that current scope, right? So here, for example, when we create a function, we increment binding. Binding is like a symbol, which can be like a variable, function, class, declaration, whatever. So we increment in the current scope, right? Because in the current scope, we've created this new binding. And then for the function itself, we create a new scope, right? Because function creates a new scope. And that inside of that scope, we set that newly created scope to async if the function declaration is in fact async. Yeah, so this is how it works. Yeah, and there is TSX and AI for some reason called it TypeScript React, even though that's not necessarily the best name. I'm gonna rename that later, but this is kind of how it works. You don't have to use the macro, but then you kind of have to do these things by hand. So, for example, we have to provide both the language as a value, so we can actually during building call things uh, on it, and then we also need the very same thing but as a stringified path, so we can literally include it in the output in the compiled file. Yeah, so for example, you would have to kind of duplicate these things, and creating the extensions like this or the handlers would require you to at least put the ampersand here, which would make it a little bit bulkier. So you could do that, but I think this is slightly nicer to do, but it's the same thing. Okay, so those were kind of all the supporting structures. And now to the kind of main thing, which is the QuickScope build. So I wasn't sure at first if I should just like append line by line raw strings. I tried that at first, but I didn't like it. It just didn't feel right. And then I found out that there is this quote thing, where you can just write Rust. You get all of the nice highlighting, and then you can just transform that into the string that you actually add into the file, and you don't add it as a like a single line. You can add as many lines as you want, and we also prettify it at the end, so the output is actually pretty. And maybe I can go and look. I can actually show you how that looks. So here in the build, there's one of these cached builds, and in out there is QuickScope RS, and yeah, I believe this is the latest one. And as you can see, obviously it like there are no like new lines because it doesn't really need that, right? Yeah, but all of this is like valid Rust code. Yeah, and it's dynamically generated. So for example, here, this is kind of the biggest magic, I would say, right now, is this is the visit TypeScript, right? So if we look at TypeScript, so here we have like program, else clause, finally clause, and then we create scope. Oh, I lost it. And here that I'm gonna put it kind of like side by side. Okay, now where did that disappear? Okay, so as you can see, this gets kind of translated or compiled into this, and I don't know why it's doing this. Why it's like what scrolling? Okay, I've just started using that yesterday, so I might not be proficient in navigating around in Z. Yeah, either way, this is one of the main magic things that's happening behind the scenes in the QuickScope build, which is that we look up the actual node IDs for these named node kinds, and we then embed the IDs, which means that instead of having to do allocations and having to be comparing variable length chunks of memory, instead, this is just a simple match on an integer, right? So that's way faster, way more efficient. So this is just way better. Oh, I've just realized maybe there should be colons. I'm actually not sure if there have to be colons. I mean, it's not screaming, so maybe there don't have to be. Huh, interesting. So maybe I also shouldn't require them here. You see, I think there is some kind of bug. It just, for some reason, it just jumped and selected a bunch of stuff. Yeah, whatever. But this is one of the main magics. And also we create a thread local. So I'm kind of starting at the end instead of showing you the build script. I'm showing you the output of the build script, but whatever. So there is this thread local parser TypeScript and parser TypeScript React, which is an instance of this TreeSitter TypeScript language TSX, and we do into to get the language. And then, more importantly, there is this analyze function, which is also built completely dynamically. And here we dynamically build this match. And here I was debating whether to also use some kind of like integer trick for these. But then I found out that if the strings here are short, so they can fit into U64 or even use U32, then kind of behind the scenes, I don't know on which level, if it's like LLVM or if it's on the Rust compiler level, I'm not sure, but it translates it basically into just integer comparisons. So I don't have to do that. You know, my plan was to create a static O1 hash map, which using the phf crate, I believe. And then just here, instead of doing match first, I would check if that thing exists in the hash map, which is O1. And then if it does, then I get a number, and that number corresponds to a language, right? So yeah, so that was my plan. But this is just easier, and I don't think this is slower. I don't know. We would have to benchmark it. This is really not a big, like a huge difference, right? Because here we're probably not gonna have like many extensions. Most languages will have like one, right? Like Pi for um, Python, C, uh, and H for C language, and so on. So I don't think there's going to be too many. Like Rust has just RS, right? Zig has just Zig. So, and we won't have like thousands of languages here, right? I think if maybe after 1 year we're gonna have 10 languages, then that's gonna be a very good news. So I don't think even the static hash map is not worth it. Yeah. So, and then there is this whole uh, walker or walking, tree walking logic, and uh, you're gonna notice that it's duplicated, right? Because like I said, I don't want to have function pointers and then always have to like dereference the function pointer and only after that call it, because this is gonna be like, this is like the most expensive thing, walking the TreeSitter tree. So it has to be as fast as possible. Yeah, so that's basically why this is duplicated, because it's not a whole lot of code. Maybe the Rust compiler or the LLVM will eventually figure out that actually all of this is the same thing. So they will do some set of optimizations on top of that. I don't know. Um, yeah, but I don't think this hurts performance in any way. Maybe it could hurt cache lines in some way, because it won't be able to load all of the code into one cache line, and instead it would have to like jump and go here, maybe something like that. But still, I believe it's worth it. Yeah, maybe I'm wrong, and later I will consolidate this into a single function. I don't know, but right now this looks like a good idea. Yeah. So, but I try to keep this as small as possible. Maybe we will even uh, extract most of the logic and then just inline the function. Also possible. Yeah. But here, as you can see, it calls the visit TypeScript, which is the visitor, and that's basically the compile version of this, and the Z is is going crazy. But yes, I wanted to show this. So it's going to, for example, call like increment binding, increment return, and so on. Whew. Okay, so I think I've explained the whole thing in as much detail as possible. Okay. Yep. So what's next, actually? Right. So the next thing we're gonna be working on, I believe, is going to be the symbol tracking, right? Because now we have some basic metrics, and we can see actually that it works by reading through the tests. So for example, here we're like kind of mocking a file, which is a test TS, and it has this function return one. And we can see that there are at least two scopes, which is true because there's a root scope and then the function scope. Yeah, so we have these tests that test like different things. Yeah. Okay, so we can see that we have scopes working, we have metrics for those scopes working. So now, arguably, the hardest part is going to be the symbol tracking, which also has to be scoped. Yep. I've tried to keep the files here in the build as focused and short as possible, because I honestly have a hard time navigating in huge files. So for example, the scope builder here, this is how you use the quote. So I just have it in its own file like this. Yeah. And as you can see, I inline all of these calls. Again, I don't know if it's like a good idea, but I think it is. So we'll see how that performs. And then there are these two stacks that we use during walking. There is an index stack, which keeps indices of the scopes. And we just arbitrarily limited to 128 depth. Yeah, basically. And then we have a similar thing, which is created stack, which tells us if at that particular depth, a particular TreeSitter depth, so there can be 256 TreeSitter depths. So if at that TreeSitter depth, we have created our scope. Yeah, so again, that's limited. Yeah, and that means that this doesn't have to do any dynamic allocations on the heap. It just exists on the stack, which is pretty nice. Whew. All right. Yeah. Okay. Any questions before I start working on the actual? Okay, I think there is just one person, and maybe that's me. So, okay, I can close this. I don't need this. All right, so that was 1 hour of explaining my, I would say, 2 weeks of work. Okay, now I will actually have to start thinking, because explaining all of this didn't require too much thinking. But now, like I said, arguably the symbol tracking is the hardest thing, and I'm not a Rust programmer, and this dynamic building and using these quotes is pretty new to me. So I will probably feel very lost. So maybe most of what I'm gonna do now is just going to be and maybe then asking AI to assist me. But yeah, but I do have kind of a sketch, I would say, of some ideas for the symbol tracking. So I believe that we should have some kind of symbol index, which is going to be probably U16. And we're gonna get this U16 from a symbol based on this symbol string to index hash map, which is going to map any string into this incremental number. So actually, now I'm not sure if this should be like one hash map for the whole walk function or analyze function. I believe it should be. Yeah, which means that in any given file, there cannot be more than roughly 65,000 of unique symbols. I think that's pretty fair, right? Yeah. So we're gonna have per analyze hash map. So you see the no allocation is not necessarily true. And once we encounter a symbol, we try to insert it into the hash map, and we use the hash map length as symbol index, right? So then once we finish walking the TreeSitter tree, we will, or as we walk, we create this separate secondary tree, maybe, and then after that we walk that tree, and we're gonna keep these two, yeah, I don't know, maybe hash maps, maybe vectors, I don't know, but there will be definitely references and declarations, right? Because we have to keep track of in which scope do we declare this symbol index, right? The declarations, they have no idea uh, about the names. You know, that's the whole point. And that's also why we use a hash map here and not a normal hash map, just to make it a tiny bit faster. Yeah, so yeah, whatever. So I imagine as we walk the secondary tree, we will need parent indexes or indices, right? Which means, and now I'm not sure where this lives. I think it's in data types. Yeah, so we have scopes, right? So the analysis result gives us scopes, which is locations, metrics, scores. This is a struct of arrays, right? Yeah, it's not an array of structs, it's a struct of arrays, which means that when it comes to like locations or metrics or scores, this is contiguous memory, which is pretty nice for cache lines. So what we're gonna have to add here is some kind of pop parents, and it's going to be a vector of, and I think it's going to be U16. So yeah, we are basically saying there cannot be more than roughly 65,000 scopes per file, which is, I think, pretty reasonable. I think once you have more than 65,000 scopes per file, we can just conclude it's a very complex file and we don't like have to go into the details, right? So that's a reasonable assumption to make. So we're gonna have this parent index for each scope, and it's just going to point to an index inside these scopes, right? Because a parent is a parent scope. Yeah. Why doesn't Z keep the opened files? I think I have to write into the file, right? Because now when I open this, yeah, it closed that one file. I guess there's some setting to do this. Okay, so yeah, so we need parent, or as we here say, scope index, which is U16. So then the reference, let me just kind of backtrack my thought process here when I was creating the sketch. So then we have a reference, which is a tuple of scope index. So in which scope did we reference this particular symbol? Like I said, here we don't need or care about the name. We just care about the index, and then we can like do like a reverse lookup. And then we have a bunch of references, which is a vector of references. Okay, so what I'm thinking is that the builder will have, because this is not something we want to return, you know, like back into like to the user of this library, which in this case is going to be the ClickHouse database. So the ClickHouse database doesn't care about references. This is just an internal state, so it cannot be a part of the scopes. You know, we can maybe argue that parents also don't have to be. Yeah. Because you can always kind of recreate the parents by looking at the locations, theoretically. But in my use case, I will never, like once I do all of the metrics and so on, and when it comes to storing, I won't need to know the parents. So I believe actually the parents together with the other like references and declarations will be an internal state of the builder. Either builder, right? We have scopes here. Yeah, so I guess it makes sense to put it here. Does it? Let me just think. Well, the scope builder should only be concerned about building up the scope. But how will we tell from individual language implementation that, for example, this is a function declaration, right? Because now we increment binding, which was okay before we introduced the symbol tracking, right? But now we will want to probably say like create declaration. Yeah. So what we will do here is we will actually call create declaration, and we will have to figure out the name for that declaration. Right? So right now I don't know how to get the name, so let's just do like to do. Right? But we're gonna do it like this. And then when it comes to, did I put yeah, I'm not even sure what it's called. Blah, blah, blah. Call yield. No, okay. But there will have to also be something like oh, okay. Maybe create symbol, and then there will have to also be like read symbol, right? Theoretically, if you want to make a distinction between reading and updating, we could say update. And very theoretically, if we wanted to make our lives even harder, we could say delete symbol, right? Because after the symbol is deleted, even though you use it in that scope, after that, it should be illegal. And if there is a symbol with the same name defined higher, then it means that in that, like after the deletion, once you try to read the symbol, it shouldn't reference the symbol that was created in this scope. It should reference the one higher, right? So theoretically, we will actually want to do this. Yeah, so delete symbol will probably look up the closest symbol at this level. Right, so we will maybe also need something like tombstones, you know? And then, yeah, and then do something with the tombstones after we finished walking. Yeah, so we will have these 4 additional methods. Okay, which means, now I got a little bit lost. Which means, oh yeah, okay. Which means the builder has to have those, right? Because that's where all of these methods live, which means the data that we were talking about has to live here. Oh, okay. What was it? Parents is a back of use16. Or symbol. Okay, let's call it something different. So symbol reads, right, will have to be, and what does it have to be? So symbol reads is what we here defined as reference. So it's a vector, right? We don't need any structure here. It's just a vector of scope index and symbol index. Yes. Yes. Let me just put this down here. Okay, so symbol reads is a vector of and maybe let's call it that, symbol read, right? So we're gonna have a struct symbol read, because the tuple was nice when I was just like quickly thinking about the general structure, but I think making it a struct is more readable. It's just nicer. And I don't think there is any difference in how they're stored in the memory, but I might be wrong. But I just wouldn't necessarily expect them to be different. Yeah. Ooh, hello. Justus Flugel. Justice. I don't know how to pronounce your name. Sorry. And sorry that I realized that you wrote a message. Now, I don't have any notifications set up. We're working on in very short, because I've spent the first hour just explaining what this is about, but code analysis. Yeah, static code analysis that gives you a bunch of metrics per scope. So you can imagine, like, this is one scope, right? This is one scope. This is another scope, and scopes are inside scopes, and each has different metrics like exit count, return count, if the scope is async, call count, I don't know, throw count, and all of this. And you can compute things like cyclomatic complexity and whatnot from those. And also we are building a file-to-file dependency graph between files of any given language with weighted edges. What it means is it tells us how much the file A depends on file B, which means how many times the imported symbols are used, like how many times they are read or assigned or updated or deleted, whatever. And we already have the metrics, and now we're building the symbol tracking for each scope, which is, I think, the hardest part actually about all of this. And it's very, very, very build heavy. So basically all of the logic lives here in the QuickScope build. Yeah, in RS, we just include the build QuickScope, and the QuickScope does, or the QuickScope run in the build does all of this build trickery and magic. Yep. Oh, I don't actually see the time here. Yeah, maybe I'll have to update the config here in the TWT so I can actually see the times, and maybe set up some notifications or something. That would be nice, so I don't miss messages. Okay, sorry. Where was I? Oh yeah. So when we read a symbol, that happens in a scope, right? Which is a U16, and it happens for a symbol, which also happens to be U16. I guess we can also create symbol update. And actually, we can just call this simple action because all of them are going to be the same, I guess. Yeah. So let's do this. And let's just copy them several times. So we're gonna have create, read, create, okay, read, update, delete. So a good old CRUD. Yeah, maybe later I'm gonna somehow consolidate this or whatever. I don't know. I actually don't know. Yeah, up until now, I haven't really thought about the use cases for update and delete, honestly. So, you know what? Let's just delete them for now, and let's just operate on create and read. Yeah, I think that's gonna be easier. Yes, scope, blah blah blah. And then when it comes to declarations, okay, so here I said that for this particular scope index and symbol index, I am creating a declaration index. Why did I do this? Yeah, I've created this 2 days ago, this kind of sketch of how could how this symbol tracking could work. And now I'm having a hard time deciphering what I meant. Hmm. Okay. Okay. Yeah, I think I see. So as I walk scope by scope, I will actually follow the parent indices, right? So I know the scope index of the current scope I am in. So I go from, okay, let's imagine there is some scope, and inside a scope, I'm reading a symbol. I'm using a symbol. We shouldn't call it read, we should just call it use, whatever. And now I have to figure out where is this symbol, what is the closest scope where this symbol is declared. Okay. So what I do is I first look at I take like itself, right? So the scope I'm currently in. And I ask about the symbol index. So again, there is this symbol string to index. So I know that the symbol is, I don't know, X, yeah. So I look up a symbol index for X. If I get none, it means X is not defined anywhere, which means I can completely skip the whole lookup, right? If it is defined at least once somewhere, then I get symbol index. So then I create this scope index and symbol index. I use that as a key in this a hash map or hash map. And I ask, is there declaration for this combination of scope and symbol, right? And if there is, it means I get back the declaration index. Okay, and where does the declaration index point? That's the mystery, because here I don't mention declaration index. But I think yeah, okay. There are two things, two distinctions, kind of. Because, like I said at the beginning, this is not a general code analysis thing where we care about usage counts of all symbols, right? The only reason why we are doing all of this complexity is to do weighted edges for the file-to-file graph, which means that the declaration index actually, okay, okay, yeah, I want to say it should actually be import index, but okay, yeah, it has to point somewhere, right? There has to be something that tells us, yes, it exists. So it could either be, yeah, it could be either. It could be like true or import index, right? Something like that. Or it could be declaration index, which is a vector of either something or import, right? It doesn't matter which one we use, but there has to be some kind of like either this or that, because we need to make a distinction between a regular symbol declaration and symbol declaration done specifically via an import, right? That's important, because what we care about is incrementing some kind of counter. So yeah, maybe I will just move this out of here. I don't know. Let's put it here, whatever. And so when it comes to these general structs, I have to have I need to have an import. I need to have a struct import, and that is going to say source, like, hey, I have this source, which is the import from, right? So it tells us the from. And also later, we're going to figure out how to expand or resolve that path or name, right? Because in Rust, for example, you don't say like import from, and now you say the path. You don't say the path. But still, it would be nice if we could resolve it into a relative path from the root of the repository. And the reason is, you could import the same thing from the same file, but using a different path, right? Because things are, relatively to each other in different places. So we somehow have to resolve it. But yeah, the source is going to be either the resolve source or the like raw source, which we then try to resolve, whatever. And then there has to be a count. And I guess we are okay just with U8, right? Or okay, let's be generous and let's just call it U16. Yeah. Okay. Yeah, so I guess there will have to be a vector of symbols. So, and now how do we structure that? What's the most like optimal thing in Rust? I'm thinking, I think in Zig I would use tagged unions, right? So it's kind of like a enum where the enum also, like one of the options in the enum can also have a struct essentially. So that's what we would do here. We would do like enum, like import and non-import. Yeah, I don't know, like normal or import, or yeah, I don't know how to, or we would say a local and I don't know, non-local. What do you call it? External, internal. Yeah. So I would do something like this. So I would say symbol, symbol. And actually, I don't know how to write enums in Rust, so I don't know if this syntax is right. I'm just kind of uh, YOLOing it here. Okay, so we need internal, external, and the external has to be the import. So now, how can I do this? So internal is just internal, like it doesn't have any other data. We just know it's internal, like cool, right? So like internally, Rust can encode it as just like theoretically just 1 bit, right? And then there's external, which is actually an import, which has source and count. So then I could say type declarations equals a vector of a symbol. Let me call it symbol declarations, right? And then we're gonna also have type symbol references, which is the reads, as we called it before. And that's simply a vector of U16, where the U16 is an index into this vector. Yeah. In Zig, I would just make it a pointer, but if I understood correctly, in Rust, using pointers is like unsafe. So you actually want to use indexes because it's just like provably safer, right? I think I got that right. So if we go back to the scope builder here, actually let's rename this, right? So declarations and references. So symbol declarations and symbol references. Yeah, I think that's right. So let me just go through that again. So once we walk the whole TreeSitter tree, or okay, no, I'm starting in the middle. Let's start at the beginning. So as I walk the TreeSitter tree, I build obviously scopes with parent pointers. And every time I see a declaration of any kind, I create this symbol declaration. Let me just pull this here. Yeah, where symbol declaration is a vector of a symbol, where symbol is an enum, which is either internal or external, which is an import, which has source and count. So yeah, so when I encounter import, I say, hey, symbol declarations vector, push external import with this source and count 0, right? And then every time I see a reference to a symbol, which can be theoretically both for reading and updating or deleting, but for deleting, it doesn't really make sense, right? For updating, it could make sense if it's like an object and we're like updating something on that object, which could also make sense for deleting. So, yeah, so whatever. If it's not like creating the declaration, right? So if it's for anything other than creating declaration, we are basically just referencing the symbol. We add it into symbol references. Okay. Okay. And here we cannot have just use 16. Yeah. You see, going through what you just did is good because then you'll realize you fucked up. Yeah, I completely forgot about this. So actually here we have to, yeah, this is the symbol action, right? Yeah. So let me just move this. So symbol reference, right? Yeah. So what we do is every time we encounter a reference, we obviously know in which scope index we are, and we either get the symbol index from the hash map or we insert it, which also gives us back the index. So based on those two numbers, we create the symbol reference and we just push the symbol reference. Okay, that makes sense. The fuck? Smart detection. I don't understand what this is. What is this? Tenacious, they're their best viewers. Oh, I see. Nope. Oh, I didn't know that. Twitch added spam detection. That's cool. Thank you, Twitch. Okay. Okay. Yeah, I can move this here back and close it. Okay. So yeah, so that's the like how do we fill up this data, right? And then so once we finish walking the TreeSitter tree, we will do a second pass, but not over the TreeSitter tree, but over symbol reference vector, right? So we go reference by reference. And what we do is we take the scope index, we look into scopes at that index. No, sorry. Yeah. Sorry. My bad. No. Something doesn't add up. Something doesn't add up. I think this is wrong. The symbol declaration shouldn't just say, hey, I'm internal or external. It should say where. Yeah. So it should say, yeah, it should be the A hash map. Yeah, my bad. It should be the A hash map, right? And the declaration index, yeah, it's not actually index. It's this thing. Yeah. Yeah, I think so. Yeah, because Yeah, well, okay. Let me just backtrack. So once we're finished walking, we start walking symbol references. For each symbol reference, we take the symbol reference and look into a hash map by that reference. And it's going to be a hash map of declaration. So just pretend this is a hash map before I actually update it into hash map. So we look into this hash map. The hash map uses symbol reference as the key. If we find it, it means the scope is references something that was created in that scope. Obviously, right now we're not dealing with hoisting, right? Or we're like we're assuming everything is hoisted at this point, which is wrong, but we're gonna address that later. So if it exists right now, we assume that great, that's the yeah, it's just good. we found it, right? If we didn't find it, we know the scope index. So we look into scopes, right? We know that scope has, okay, not scopes in analysis. We look at scopes here. And we actually look into the parents, right? So we look up the parent index for this scope index. And if there is parent, we walk up to that parent. So we get that parent's index, and then we do the same thing. So instead of the current scope index, we use this resolved parent scope index. So we actually don't have to look into the scope, right? Because we don't care about like what's in the scope. We just care about its index. And if underneath, or if for this combination of scope index and symbol index, there is a reference, right? And we just keep doing this until there is no more parent because it's a root, or until we obviously find it. Okay, good. So, oh, and if we find it, okay, one more thing. If we find it, we check its kind, right? If it's internal, we don't do anything. If it's external, we do count plus equals 1, because to create the weight on the file to file dependency edges. Whew. Okay, so this has to be a hash map, and it uses yeah, let me put this here. It uses symbol reference. Yeah, so underneath that symbol reference, there is a symbol. Yeah, this is just a bunch of symbol references. Yep. Okay. Good. Let's say we don't want to assume that everything is hoisted, which is, I think, a pretty good assumption, right? Then what would we have to change? Well, I don't think we should change anything here, right? The key is okay. It's just that when we do get a hit, when we do match and we get the symbol, I guess even the internal, so both internal and external, should have line, right? Or row. Is it row or column? Row, it's column, right? So just line number. So on which line does it appear? And okay, so there has to be different kinds of internal actually, right? There has to be like non-scoped internals, like locally scoped, and globally scoped. Yeah. Or like sorry, like locally hoisted internal. Yeah. And we don't really make any difference between a block scope and a function scope. And I hope that's not gonna cause any problems. Yeah, I'm gonna have to look more into that, into like the specific differences in different languages. But I think we can get away with just having uh, locally hoisted internal, globally hoisted internal, and non-hoisted internal, right? So obviously import. Damn. Okay, now we're really getting into like the nitty-gritty of different languages because honestly, I'm not sure if when it comes to static imports, I understand that when it comes to dynamic imports, yes, you could have like a locally hoisted external meaning import, right? But we're not concerned about dynamic imports, right? We're because when it comes to dynamic imports, you can have like a string little and suddenly it's like impossible for us to statically figure out what it can import from, right? We could say, okay, if if it's actually not dynamic, right, in a sense that the path is dynamic, we still can count it in. Yeah, but I'm just making it more complex. So let's just say we are not concerned about that. So let's say imports always have to be non-hoisted, right? And what was the point I wanted to make? I forgot. Damn. Yeah, external, non-hoisted. Oh yeah, I wanted to say that I'm actually not sure if in any language. Oh, sorry. No. Okay, okay. I'm stupid. Or am I? Because, for example, in Zig, there is one uh, code style, we could say, where you put the imports at the very end of the file because when you open the file, you just want to see the logic, right? You don't want to see 20 imports, 20 files of imports. So you put the 20 files, 20 lines of imports at the very end because it's the least important thing in the whole file, right? Which means that by definition, uh, actually imports are always hoisted, right? Oh yeah, yeah, I got that the other way. But actually, what I wanted to say, I'm not sure about this, like how this, if this is true for all languages. So maybe actually we will have to have uh, like hoisted external and non-hoisted external. Damn. Okay, I'm just making it more and more complex. But I don't think this is like a me problem. I think this just uh, mirrors the complexity of programming languages, right? Yeah. Okay, I'll have to look into this, like read through. I'll have to figure out which languages we actually want to support, because we could say that, for example, we don't care about Haskell, right? But I do care about like Rust, C, Java, Go, Zig, JavaScript, TypeScript, Python, um, PHP, Ruby. Yeah, so I'll have to figure out which languages we definitely want to support or maybe want to support, and then do a research on how how do they work when it comes to hoisting imports, right? Like first of all, hoisting in general, if there are like any other patterns than this, and how how is it when it comes to hoisting imports? Yeah, because from the top of my head, I have no idea when it comes to like so many other languages, and I don't want to just spend hours researching here on stream. So I think that's it for today because I'm gonna have to do the research and figure these things out. Yep, makes sense, I think. Okay. Yeah. I'm alive. I'm alive. And I'm programming Rust. Would you believe that? And it's not just normal Rust. Um, I'm putting all of my logic into build, and I'm comp time maxing. Yeah, because obviously I came from Zig, right, where like everything is comp time, and I just really missed the comp time. But I need Rust because TreeSitter support in Zig is shit right now. It's not mature enough. Yeah, and I'm not trying to make this like a general open source library for anyone for any use case. I just have a very particular use case, so I'm completely okay uh, hard coding things or not allowing any modularity, um, which is pretty nice because then I can really play around with generating like super optimized and static code, which is pretty nice. Yeah. Oh, yeah. How are you doing? Are you still programming in Rust? Thank you. Yeah. I'm trying to be more active. Yeah, and I really started liking just putting it out there, you know? So anything that's on my mind, I just put out there. Yeah, sometimes people agree with it, sometimes people completely ignore it, but yeah, that's life. Yeah, and also recently I've been playing more and more with like AI stuff. I've done some uh like big data analysis on like uh all the history of GitHub and uh uh, basically all uh, public code from GitHub, and I tried to create my own embedding model. I'll definitely get back to that. I created something, but it's definitely not winning benchmarks, so I have to think more uh, in depth about that. But yeah, it's exciting, and I'm building agents, as you might have noticed from my Twitter. Yeah, so it's exciting. You are no longer you don't program in Rust. I've switched to VHDL. What in the name of the Jesus is VHDL? VHDL, very high speed integrated circuit. Oh, so it's just hardware. Wait, how do you program this? Oh, it's FPGAs. Oh, so you actually program this. I actually have very vague idea of what FPGAs are and how they work. I just kind of know it's like programmable, like dynamic hardware, so you don't have to like hard code the hardware in a way. But I actually have no idea how that works. But either way, what do you use this for? I'm really curious. Like, what do people use this for? Hardware description language, model the behavior and structure of digital systems. Interesting. Entity, blah blah blah. Kind of looks like Fortran or something like that, which is not a good thing. So like respect if you program in this, it looks horrible. Importing LLMs to FPGA. Okay, yeah, yeah, because GPUs are too expensive. So, what's the next best thing that you can do? Oh, it's just program your own FPGAs. Yeah, makes total sense. Yeah, that's cool. Okay, I'm toast, and I'm actually hungry. So, yeah, like I said, I'm kind of done for today. I'm gonna have to do some research about hoisting and imports in different languages to hopefully finish this variable tracking thingy, and then hopefully once this is done, we have to obviously do this over the history of comets, right? So that's going to be the next step. The next step is going to be actually saving this in a database. We can kind of skip the like what do we do after we've put it in the database kind of thing, and we can start working on the agents, the minions that are going to be acting based on these metrics. uh, so yeah, that's kind of the high level plan. Oh, I see. Okay, I'll read something about that, or if you want, you can tell me more on Discord. Okay, so that's it for today. Thank you guys for being here. Thank you for the